Before we can even start about solving exponential equations, does anybody remember this? Would you please get yours out? You're really going to want to have this out today as we're going through this stuff and as you're working through your homework. Because maybe you remember these, maybe you don't. If you don't remember them right off the top of your head, you have an excellent reference source right here to look at real quick to figure stuff out. Okay? So before we even start, let's make sure we remember the product of powers rule. The product of powers rule says if I am multiplying like bases, what do I do with the exponents? Do I multiply the bases? Do I even mess with the bases? I don't even mess with the bases. I just add the exponent. See, this is an A, this is an A, this is an A. It doesn't change value. It's all the same value, right? If I'm multiplying like bases, I add my exponents. Do you remember that one? Okay. I know you know all of these. I'd just like to refresh your memory real quick before we start. Is that okay? Okay. If it's not okay, I'm going to do it anyways. Okay. Power of powers. Okay. If I have a power to a power, do I mess with the base? No. I leave the base alone. What do I do with the exponents? I multiply them. Okay. The other one that you're going to need today is this one here, negative exponents. Okay. A to the negative power is the same as 1 over a to the power. So if I have 1 over 2, can we go backwards? What is that the same as? 1 over 2, what should that be? 2 to the negative 1, because 2 doesn't have a power on it, does it? So it's 2 to the first. If I want to bring it up, it's 2 to the negative 1 power. Do you remember that? Yes? Okay. So I'm going to keep this just to the side. You're not going to be able to see it on the camera, but no, it's just right here to the side. In case I need it, I can pull it back on the screen. Yes? Okay, now let's talk about solving exponential equations. Now that we have remembered all of our exponent rules, let's solve some equations with them. Okay? So remember I told you we're going to start off pretty easy? 2 to the x power equals 2 to the 4th. So you guys are giving me some weird looks. Yes, it really can be this easy, right? If 2 to the x power equals 2 to the 4th, if the base is the same, what should the exponents also be? The same. So am I allowed, once I get it set up like this, am I allowed to just go over here and write x equals 4? Am I allowed to just ignore the bases for a second? Because they're already the same. Shouldn't the exponents be the same? So can I do this? Yeah, that's done. What about this? 3 to the x plus 5 equals 3 to the 7th. Are the bases the same? Yes, then what should also be the same? The exponents. So can I write x plus 5 equals 7 and solve that equation? Yes. So subtracting 5 from both sides gives me x equals 2. Is it correct? Go back to the original equation and substitute in your answer. 2 plus 5. 7, that took a little bit too long, but that's okay. It's still Monday morning a little bit, right? So 2 to the 7th equals 2 to the 7th. Is that true? Do we care? I don't know why I said 2. Thank you for mouthing at me 3. That was very kind, okay? 3 to the 7th equals 3 to the 7th. Do I care what 3 to the 7th is? I do not. I do not care what 3 to the 7th is. I know that 3 to the 7th equals 3 to the 7th, though. Does that make sense? Okay. So are we good on that one? Okay, how about another one? 4 to the x plus 7 equals 4 to the 2x minus 5. Are the bases the same? If the bases are the same, what else should be the same? Absolutely. So x plus 7 should equal 2x minus 5. How do I go about solving this one? Subtract x and add 5. Good. So x minus x is 0. 7 plus 5 is 12. 2x minus x is x, and negative 5 plus 5 is 0. X equals 12. Is it correct? 12 plus 7. 19. 19. Okay. 2 times 12, 24 minus 5. Does 4 to the 19 equal 4 to the 19? Do we care what 4 to the 19th is? No, it's some crazy, ridiculous big number, right? I care that 4 to the 19th equals 4 to the 19th. We good? Any questions so far? So, what happens when it looks like this? Dun, dun, dun. This is when we panic? No, rule number 1, right? Rule number 1, don't panic. Because we're in a position where we can actually make the bases the same, can't we? This is a base of 4. This is a base of 2. Do you agree with that? That was just an observation, okay? Could I write one of these numbers as a base of the other one? I can actually write both of them as a base of the other one, right? If I wanted to write 4 as a base of 2, it would be 2 squared, right? If I wanted to write 2 as a base of 4, it would be 4 to the 1/2, okay? Do you want to deal with fractions or not? Not if we can help it, right? So what if we wrote this problem as 2 squared? Is 2 squared the same as 4? It is, right? What do I do if I have a power to a power? I multiply. So is this side the same as 2 to the 2x power? Equals 2 to the x plus 5 power. So my bases were not the same, so I did what was necessary to make them the same. Now they're the same. What else should be the same? The exponents. 2x equals x plus 5. If I subtract x from both sides, what do I get? X equals 5. Go back to the original problem up here. 4 to the 5th power equals 2 to the 10th power. This time, do I have to care what 4 to the 5th power is? I do, because I need to know, does it match 2 to the 10th power? And that's where our friendly neighborhood calculator comes into play. 4 raised to the 5th, enter. 2 raised to the 10th, enter. Are they the same? Yes. Psst. Okay. So is this the correct answer? Yes. Okay. Any questions so far? Okay. 3 to the x minus 2 power equals 243. Can I write one of these as the base of the other? Just as before, I could rewrite both, but which one are we going to choose so we don't deal with fractions as our exponents? What's going to be our base? The 3. Okay, so 3 to the x minus 2 equals 3 to what power? So I'm going to start a new document because I don't want to save my old one. Please make sure you're doing all your work in a calculator page, not a scratch pad. Okay, I've had some issues in the last couple of days with people trying to use scratch pad and things not working. Okay, so there's a couple ways to do this. 3 raised to the second, I already know, so I'm not even going to try that one, right? Because that's 9. What if I did 3 raised to the third? Well, that's 27. 3 raised to the fourth? Well, that's 81. 3 raised to the fifth? Ooh, that's what I need, right? Wait, so I just like guessed to figure out the answer? Is that okay? Guessing's okay? All the time? No, not all the time, right? In today's lesson, it's okay. Because here's what you need to know. There's totally another way to do this problem. You are not ready to learn it yet. I don't mean that disrespectfully in any way, shape, or form. It's just not time yet. Right now, it's time to teach you how to do this problem this way. When it's time for the new way, I promise I'll get there, but not until then. That, my friends, is called foreshadowing. I know that's an English word. Sometimes we can use it in math. It's cross-curricular. Uh-huh. It gives you something to look forward to besides just spending time with me every day. Okay? For now, are we okay with this? I rewrote this base to the smallest base I could find. Usually the smallest base I can find is what I want. Okay? So now that the bases are the same, what's true of the exponents? They should be the same. So if I add 2 to both sides, x should equal 7. What is 7 minus 2? 5. That took a little too long, but it's okay. I still love you. 3 to the 5th power equals 243. Is that true? Yeah, then I know this is the right answer. Okay. What do you think? 16 to what power is 64? Well, it's not squared. That's already too big, right? So is there another base? Is there a lower base that I can go to that's not even one of the bases that are here? 8. 8 to what power is 16? 8 to what? 8 squared is 64. 8 to what power is 16? So maybe it's not 8. What about, what about 4? 4 to what power is 16? 2. 4 to what power is 64? 3. Okay. Is there another base I could choose? 2, right? I could definitely choose 2. 2 to what power is 16? No, I agree with you that 2 times 8 is 16, but I'm asking about powers, right? So 2 to the 4th power is 16. 2 to what power is 64? 6. And you just knew that off the top of your head, or you experimented with your calculator? Yeah, it's totally fine. Remember, I told you today guessing is okay. It's not really guessing, it's like educated guessing. We know 2 to some power is 64, we just have to figure it out. Okay? Some people know off the top of their head, not everybody does though, so let your calculator help you out with that. Okay? So do you want to use, what base do you want to use? Wait, there's more than one possibility? Oh my goodness. So if you come and check your answer on my answer keys, and we get the same answer, but we use different bases, is that okay? Yeah. Okay. You guys couldn't see her a second ago, but she even said we could actually use 16 to the 1.5 power, because 16 to the 1.5 power is 64. Do you want to use decimals? Probably not. Okay. But that is a possibility, just so you know. So tell me right now, do you want to use 2 as a base or 4 as a base or 16 as a base? Your choice. 2? Okay. So how are we going to rewrite 16 as 2? 2 to what power is 16, you said? 2 to the 4th power is 16, and I still have that x up there, right? And we said 2 to what power is 64? 6. And I still have the x plus 3 up there. 2 to the 4th raised to the x. That sure looks a whole lot like power of powers, right? What do I do with those exponents? So 2 to the 4x power equals 2 to the 6x plus 18, right? Because I just distributed here and here. Once the bases are the same, what do we do with the exponents? If the bases are the same, the exponents are the same. 4x equals 6x plus 18. To solve, I'm going to subtract 6x from both sides. Negative 2x equals 18. X equals. There's 2 times that people panic when they're doing these problems. The first time people panic is when they get a negative number as their answer. The second time people panic is when they get a fraction as their answer. When have we not ever been allowed to get negatives or fractions? To be fair, there's times, right? If we're solving a square root equation, we don't want to get a negative under the square root, do we? I get that, okay? But this is not one of those times. 16 raised to the negative 9th power. There's the answer. 64 raised to the negative 9 plus 3, so negative 6. It doesn't matter what it is. It matters that they, oh, you can't even see it. Calculator's being a jerk. It doesn't matter what it is. It matters that they are the same. So is this the right answer? Yes. It's okay that it's a negative, and it's okay if you get a fraction. Now, is it possible that you're wrong? Yes, absolutely. But don't worry about that. Okay? One more? Okay. Let's see. Can I change something real fast? Not change it, just add something to it. Is that okay? I want to put a 4 in front of that x. So 1 over 6 equals 36 to the 4x plus 5 power. Okay? What kind of base do you think we want to use? Well, the numbers we're dealing with are 6 and 36. What kind of base do we want to use? Yeah, how about 6? That's a good choice, right? 6 to what power is 1 over 6? 1 over 6. Isn't that really 1 over 6 to the first power? So how do I rewrite that? 6 to the negative 1. Okay? So 6 to the negative 1 equals, what's 36 as a base of 6? 6 squared, right? 4x plus 5. Everybody okay with that? Okay, 2 people, excellent. So here, I do that, right? So I have 6 to the negative 1 equals 6 to the 8x plus 10. Good? If the bases are the same, Exponent should be 2. Negative 1 equals 8x plus 10. How do I solve this? If I subtract 10 from both sides, like you suggested, I get negative 11 equals 8x. I purposely try to put you outside of your comfort zone because this answer not only is a fraction, but it is negative. That's why I even changed, I added the 4 to it to make sure for sure we get a fraction, right? So if I take negative 11 over 8, I'm going to zoom in real quick so it's not a jerk again. So I'm going to say 36 raised to the 4 times negative 11 over 8 power, and then plus 5. Huh. Does 1/6 equal 1/6? Then is this the right answer? 100% sure, right? I know for sure that's the right answer. Are there any questions? How many times did I refer to this through our lesson? Couple, right? So don't you think it would be a good idea to have it on your desk as you're working through the problems? Yeah, okay. On the worksheet, the problems that I want you to do are all the evens except for 1 and 5. Except I meant to say odds. Can I start again? I want you to do all the odds except for 1 and 5. 1 and 5, I want you to do 2 and 6 instead. So all the odds, except not 1 and 5, but 2 and 6 instead. Does that make sense? Any questions? Peace.